It's such a pleasure to be here. I love coming to Holland. Holland is a great country. I've been here before. Thanks for having me back. I have a question. The question is, why are you a developer? Why? Now, for a lot of you, I think the answer is because you couldn't not be a developer, right? Writing code is what you do. You do it for free. I will not tell your boss. Another reason. We know that the modern world, our world, runs on software. The world runs on code, more and more and more. And so the work that we do is really, really important. And that's a great thing. But there's a third reason why I think many of us work in this profession. And it is because we like new things. People who don't like change should not work in the technology industry. And all of us in this room, I suspect, like change. We like the shock of the new. We like the fact that in our world, there are always cool new technologies that let us do even more cool new things. Well, that's what I'm here to talk about this morning. My goal this morning is to talk about what's happening in the world of software development, specifically in the Microsoft environment. I'm going to talk about building modern applications. Because think about this. Think about this. We all know that traditionally, we've built apps where the clients ran on desktops and laptops. Great. The servers ran in on-premises data centers owned by our companies. And as far as the process of building and running those apps, the thing called ALM, App Lifecycle Management, there were the traditional three aspects. There was development, there was operations, who then could deploy the apps for us, and there's governance, making decisions about all of these things. Traditional world, clients, servers, ALM. This is the world in which many of us still work today. But it's all changing. It's all changing. All three of these are changing. Here's what's changing. First of all, rather than just caring about desktops and laptops, we now care deeply about clients that run on tablets and phones. Rather than relying only on servers that run in our own on-premises data centers, we now can use servers that also run in public cloud data centers. And rather than having the traditional three aspects of ALM, development, operations, and governance, for delivering an application, we're now seeing the rise of these ideas of continuous delivery and what's called DevOps. And the remarkable thing is that all three of these are happening simultaneously. We are seeing big changes happening in each of these areas all at the same time. In fact, they're tied together. I'll show you later, for example. The ALM changes are very much driven by what mobile and cloud applications make possible. So thinking of all of these things in a unified way, as a whole, as a totality, is, I believe, the best way to understand what is happening to our world. So, I'm going to do that. I'm going to walk through each of these three areas in the next 45, 50 minutes and talk about what's happening in the Microsoft world specifically. Let's start with clients. In my diagram, what this means is here. Tablets and phones join the traditional world of desktops, laptops that we've worked in for quite a while. Now, how should we think about this? How should we think about this change in clients in our environment? If you want to irritate me, if you want to really annoy me, later on today after this talk, find me somewhere and say, David, did you know? We're living in the post-PC era. That will really irritate me. And here's why. It's because we are not living in the post-PC era. Come on, what is on your desktop at work? Is there a monitor, 2 monitors, 4 monitors? Is there a keyboard, a mouse? Is there processing and disk? Yeah, that's called a PC, people. Going to be there for a long time to come. We are not living in the post-PC world. The truth is, it's much more accurate to view this not as the post-PC era, but as the PC plus era. PCs, in the conventional sense, certainly matter. But tablets and phones matter critically as well. A much more accurate way to think about what's happening in the client space today than this vogue phrase of post-PC era is to recognize that this is the PC plus era. And that's a big change. That's a big deal. And so let's talk about what different organizations, different vendors are doing in this space, specifically around operating systems. We know that we care about desktops, laptops, tablets, phones. We also know, from paying attention, that these lines get somewhat blurry. The line between tablet and laptop, for example, gets really blurry as devices emerge that can live in both roles, depending on what you're doing. Still, that breakdown is worth thinking about. And in the context we care about here today at this event, the 3 most interesting vendors in this space are Microsoft, Apple, and Google. And so let's talk about what those 3 have done in this PC Plus era with operating systems. And let's begin the story with the iPhone in 2007, where Apple introduced iOS, a new OS designed for mobile devices. Apple then realized that iOS worked quite well on tablets. There was a market for tablets, great. For desktops, however, Apple has argued that desktop operating systems like OS X are still the right approach. Apple, for example, has said that touch is not useful on desktop and laptop screens. Okay, great. Google has pursued what some have argued is a derivative strategy with Android on both phones and tablets. Google also promotes the idea, though, of another OS on desktops, Chrome OS, which is an OS in an interesting sort of way, but still qualifies. So the notion here is to view these things as different. Microsoft's approach to this space is not the same. Microsoft says, well, you know, we think PCs still sort of matter. And so Microsoft, it appears, starts there, Windows 8. Windows 8 for PCs, desktops, laptops. Microsoft has observed, however, that you can also run those same kinds of things on tablets. Microsoft goes the other way, not from phone up, from desktop down, and says, hey, let's run the same OS on desktops and laptops that we do on tablets. On phones today, Microsoft's offering is Windows Phone 8, not quite the same. However, Microsoft says to us that they're going to be converging these over time. What are we seeing here? We are seeing classic Microsoft strategy. This, to me, is an expression of Microsoft's strategy DNA. It's what they do. They provide unified solutions across diverse environments, like Windows and Windows NT a long time ago. It's a similar idea here. So, their approach is somewhat different. How do you do this? How do you do this? How do you make the same operating system work on desktops and laptops and on tablets? How do you do that? Because everyone in this room has a smartphone. Most of you probably have tablets, and you know that the way applications behave on those newer mobile devices is not the same as how they behave on desktops and laptops. You know, for example, they're touch-driven typically. You know that the application's UIs behave differently, that their life cycles are different. They're just different in a bunch of ways. So how do you do that? How do you make an operating system such that it can work effectively on desktops and laptops and in these newer devices that matter so much here in the PC Plus era? Here's how Microsoft chose to answer that question with Windows 8. They said, well, okay, we've got these core OS services. And of course, we've got to support the classic Win32 desktop applications that folks like you have built for a long time. We build those apps in Java and HTML, JavaScript and HTML, with IE or other browsers. We build them in C# and VB, C++ with .NET. We might use XAML, DirectX, other things for the UIs. That world, of course, is still there in Windows 8. But to support this newer style of application, Windows 8 also adds another approach to building apps. This other kind of app is officially called today a Windows Store app. Microsoft used the term Metro for a while. They call them modern apps, occasionally the modern UI, we just heard that. The official name is now Windows Store app, and we'll see why in a few minutes. Windows Store apps have, of course, that different UI, and they depend on WinRT, not Win32. Not Win32. Now, when you build Windows Store apps, you can still build them in HTML and JavaScript. You can build them in C# and VB and C++. There's even some .NET support. There's XAML, there's DirectX. The languages, to some degree the libraries, to some degree the UI technologies are similar. But of course the apps aren't the same. They behave differently. So, Windows 8 offers both approaches. You all know about the left-hand one. I'm going to talk a little bit about the right-hand approach, about Windows Store apps. It's interesting. It's interesting. And again, it grows out of the difference in strategy, difference in approach to operating systems for the PC Plus era. The UI, of course, is based around tiles that lets you start applications. Tiles can be alive. They can be updated while they're not even running, potentially. And of course, Microsoft defines a whole bunch of fancy UI design guidance for this. I'm curious, who in this room is running a device right now, laptop, desktop, tablet, that has this interface? Who's doing that right now? I see most of the hands. Great. Who likes it? Who likes this interface? I see all the same hands. Yeah, most of the hands. I'm not surprised. It's a somewhat biased audience, I think. I got to tell you, I like it. And I'm almost surprised by that because I tend not to think of Microsoft. I don't look to Redmond for leadership of user interfaces. But this is actually a very cool UI. I like this UI. I do. And so, as most of you know, the applications are quite different. A single app typically fills the screen, no overlapping windows. We have a world without persistent menus, scroll bars, Chrome. It's a very tablet-like user interface for applications. And this is very cool. For a developer, when you build an app, the app can accept input via touch, mouse and keyboard, or a stylus, and it all comes to be the same thing. So these apps can work as well on devices that don't have touch screens. That's important because these are not meant to be just for tablets. They're meant to also work on devices sitting on your desk, more traditional PCs, with or without touch. It's important. When you look inside the app, look at the actual technology, what you see is interesting. If I've got some Windows 8 device with some Windows Store apps running on it, those apps each run inside their own little sandbox. It's called an app container. And what that does is constrain the app in a bunch of ways. There are things the app just can't do, which makes it somewhat safer to run in your environment. Apps also have contracts. They can implement contracts, which define how they interact with the actual OS and other apps. They can say, for example, that you can access my data to search, or you can say you can access my data to copy it, like the clipboard. There's a bunch more as well. Each app has a manifest that describes what you have to know to deploy the app. It's interesting. The manifest also indicates what the app wants to do on your system, such as use the internet connection and so on. It's interesting. And the apps just behave differently. When you build a Windows Store app, you've got to build an app that lives in this world, that uses the WinRT APIs, directly or indirectly, that knows how to behave when it's moved off screen to suspend itself, There's things you must do differently than the conventional Win32 desktop application. And one more example of the synergy among these changes happening simultaneously is that every app built as a Windows Store app has automatically 100K or so of cloud storage made available for it. Why? To share things. The assumption here is that you'll be running these apps on many devices. And so you're reading a book or watching a movie or doing something else, and you move from tablet to laptop to desktop back to tablet. It can all be synchronized because all the copies of the app can share location information, for example, in this common cloud storage. So, building apps in this world is not just the same as building apps in the conventional Win32 world, unsurprisingly. Why are they called Windows Store apps? Because they come from the Windows Store. It's pretty obvious, right? The Windows Store lets you do things like find the apps. When you download them, you know they have been vetted and digitally signed by Microsoft. Not just anything can go up there. Apps are packaged in a single file for download, as I mentioned earlier. The manifest clearly states what the app wants from you. The manifest specifies whether or not, or more correctly, the manifest makes you specify whether you'll accept what the app wants you to do. Can it access the file system? Can it access internet connection? Can it use your webcam? You know what it wants you to do, which is interesting. And one more important point, enterprises can have their own app stores. You are not stuck solely with the app store Microsoft gives you. That would be kind of limiting if you were. Most of you probably work for enterprises. But suppose you're feeling entrepreneurial as this new world emerges, and you say, I want to build a Windows Store app myself and make some money. What does that look like? If you are a software vendor, an ISV in this world, and you build an app for the Windows Store and sell it to your customers, here's what happens. Microsoft takes 30% of the first 25,000 in sales, 20% after that for paid apps. For free apps, they take nothing. If your app then offers in-app purchases or subscriptions, Microsoft again will take that same cut of the revenue you receive. However, this is interesting. That's only true if your app relies on the Microsoft Store for fulfillment. If you have your own e-commerce engine to do this, then Microsoft takes nothing. So you could potentially put in the Windows Store a free app that does purchases or subscriptions via your own back end, and Microsoft gets nothing, which is interesting. Your app can also display advertising from Microsoft or others if you choose to. Great. So here in the PC Plus era, tablets matter a lot. Phones matter a lot too. So Windows Phone 8, as I said earlier, is similar to Windows 8. The UI is very similar. The UI, in fact, this UI style, as most of you know, first appeared in Windows Phone. Great. But the dev environment is not identical. It's not just the same. It has an extended subset of WinRT. So it's a subset of WinRT, the Windows Store app API, but it also adds things to it. And so even though there are other commonalities, other common OS components, common driver model, building apps for Windows Phone 8 is just not the same as Windows Store app. Not the same. So you have to do a port between those two. I'm not Microsoft, but from my perspective, from any perspective, it's clear this is not ideal. And so Microsoft keeps on telling us they'll get more similar over time. They're converging in some ways. So we'll see what happens here. But again, to me, this reflects Microsoft's classic strategy DNA of doing a unified environment over a range of worlds. So we'll see what happens here. Finally, the last thing to say about Windows 8 is this. People sometimes look at Windows Store apps and say, oh, they are the replacement for traditional Win32 apps. They say, we'll no longer build Win32 apps. I got to tell you, I think this is wrong. The truth is that both exist side by side, and both will exist side by side for some time to come. Because each approach, Windows Store apps and conventional desktop apps, has strengths and weaknesses. So when you next build a client, what should you do? Here are some things to think about in making that decision. First, do you want a touch-centric user interface? If so, well, Windows Store apps give you that, clearly. Windows desktop apps commonly don't. They can. There actually is support for touch, but it's not used very often in that world. Whereas the Windows 8 UI is built around the notion of touch. It's touch-centric. Do you want to have a central location for your customers to find, buy, and download your app? Windows Store apps do that. That's why they're called Windows Store apps. Windows desktop apps, of course, do not. They come from who knows where. How about built-in support for online updates? You get that with Windows Store apps. You don't with conventional Win32 apps. How about built-in support for roaming across devices? Again, that shared cloud storage I showed you, you get that with Windows Store apps. You don't have that built in with conventional Windows desktop applications. A bunch of pluses there for Windows Store apps. But suppose you want to use existing UI controls. Not really possible, in a straightforward way at least, with Windows Store apps. Desktop apps do that. Or suppose you want to have very broad direct access to your local device. Again, Windows Store apps run on a sandbox, app container. Windows desktop apps do not. And finally, a big one. If your new client has to run on earlier versions of Windows, Windows 7, Windows Vista, you can't do that with Windows Store apps, but you can with desktop apps. So, a few things to think about when building your next Windows client. It's a big deal. It's a big change. There's a lot going on. That's a great thing. That's why we like this business so much. And we're only 1/3 of the way through. Because there's more. There's the server transformation. There's the rise of public cloud platforms. When we build server code now, that server code may very likely run not on physical servers at our own data centers, but rather on machines in public cloud data centers. Bear with me. I'm going to take under 5 minutes and define cloud for you. But I will not do it in the way you've probably seen before. So I hope this is useful. I'm going to start in a funny place. I'm going to start with how you get virtual machines in your own environment today. And I know I've taken a sudden segue here from clients to servers. That's how the talk has to go. Suppose you want a new VM in your own organization today to do some development on or deploy a test app or something else. What do? How do you get a new VM? Answer, you talk to your VM admin. There's somebody in your company probably who does this. You say, I would like a new VM. They go through some kind of process to get approvals or whatever. If the answer is yes, they use some VM management tool to create the VM you asked for, probably on a machine owned by your group. That's how it works today. That's virtualization. Great. A wonderful advance. We all do that today. Cloud technology changes this. Because I'm going to argue that the essence of cloud technology is something called infrastructure as a service, IaaS, which looks like this. If you want your own VM and you have IaaS software, you can now do this. You can use the self-service portal, a website, to look at a library of VM images, various OSs, various sizes of VMs, and so on. You can say, I want one of those. You examine the list, you choose an image, you then say, IaaS software, please create me one of those VMs, and you get it. That VM starts running on some physical server in some data center. IaaS means self-service VMs on demand running on pooled hardware. And if I do IaaS in my own data center, the result is commonly called a private cloud. If I do IaaS in an external data center, the result is commonly called a public cloud. Now, if I rule the world, I would go find the person who defined the term private cloud, I would hunt them down, and I would lock them up for life. Because it is the most confusing term. But this is what it means. Private clouds means IaaS in your own data center plus more. Notice, in both of those cases, I'm not saying the cloud is just IaaS. No. There's always more. But IaaS, VMs on demand, running on pooled hardware, is the fundamental defining technology that makes a cloud a cloud. And so that's why they're called private and public, because IaaS can be applied in both places. The truth is that we do those things for different reasons. We use private clouds to make our own data centers more efficient and more effective. We use public clouds to give us access to massive external data centers with great scale and usage-based pricing. Don't think for a minute that because those technologies both have the word cloud, they're interchangeable in some way. They're not. They're not. Similar technology, but very different benefits. You want them for very different reasons. And so, I'm going to talk here about the bottom part of this, about public clouds. If you care more about the private piece, come to my talk at 1 o'clock today. I'll look more at that. But here, let's say a few words about Windows Azure. Windows Azure is a public cloud platform that provides computing resources accessible across the internet. Microsoft has data centers around the world, great, in which you can run your apps and store your data. Now, I have given a variety of talks on Windows Azure in countries around the world. In every single talk I have ever given, the very first question asked is some version of, can a public cloud platform really keep my data and my applications safe? And you know, really, what I'm showing you here, this is the polite version of the question. Far more often, it's phrased as, David, are you out of your mind? Do you really think we're going to put our apps and our data in data centers owned by some third party in some other country? Turns out that one of the Microsoft Azure data centers is here in Amsterdam, which is a great thing for you. But going across national borders can be an issue for many organizations. And so, that's the question. People say, how can I rely on the security of these data centers? But I got to tell you, this is in fact not a question about security. It's a question about trust. The truth is, you have to learn to trust your cloud provider. Because we think about it as a security question, because we are accustomed to having our own data centers in which we are responsible for things like firewall settings and disaster recovery plans. We're used to that. But in this world, we run our apps, we store our data in other data centers for which, in this case, Microsoft has responsibility for those things. They will not let us come to data centers and verify firewall settings. They won't do that. We have to trust them. Now, as you know, this same kind of thing has happened over and over and over in our world, where at first something seems terribly scary, like sending credit card numbers across the internet, manufacturing in China, building software in India. These things all seem very scary. But if they have real benefits and if they prove trustworthy over time, we learn to trust. And my opinion is the same thing's happening right now with public cloud platforms. People are learning to trust, with some hiccups clearly, but we see trust building over time, I think. And you know what else? People are so irrational about trust. They are so irrational. I ask you, what is the world's scariest technology? Is it nuclear weapons? Is it some kind of bio-warfare? No. The world's scariest technology is Windows Update. Think about it. Every Patch Tuesday, Microsoft puts in your operating system whatever code it feels like. And you trust them. That code could be doing anything. The level of trust we have in Microsoft already with Windows Update far exceeds what we ask them to do with a technology like Azure. People are just not rational about this. Whenever I talk about public cloud platforms, this is always the first question. The second question, though, is always this. It is, wait a second, can I still meet what might be some onerous regulatory requirements in the cloud? Because all around the world, governments and others have laws and regulations about computing. The answer to this question, sadly, is more complex. The answer is you have to understand the rules that apply to you. And that can be difficult because there are different rules in different vertical markets, financial services, healthcare, government, and there are different rules in countries around the world, Netherlands, UK, US, whatever. The result is a matrix of laws and regulations. You must understand the ones that apply to you as a developer. If you choose to use Windows Azure, you want to be aware of whether you're running afoul of national laws. You could expose your firm to real problems. Now, my experience with this has been that when companies look at this seriously, they find these are less onerous than they originally thought, in most cases. I met with an IT leader at a French bank in Paris last fall who told me that his company had done a detailed survey of all their data against these regulations for them in France. And they found that 90%, 9/10 of their data, could legally be stored in public cloud data centers. When folks look at this, in my experience, they often find that the rules aren't as onerous, as strong as they were concerned. But still, be aware of this. Breaking the law as part of building your app is not a good idea. All right, technology. I want to talk to you about what Windows Azure data centers look like. You have to understand what they look like to make sense of how to write apps in this world. Enterprise data centers, the kind you have right now, often look like this. They've got servers, pretty expensive servers that cost 10, 20, 30, 40,000 euros. They've got SANs for storage, which cost even more. They have nice networks tying together. The servers all run hypervisors and virtual machines. Each VM is running some server OS, like Windows Server or some Linux version, and there's an app or workload of some kind in that VM. To ensure higher reliability, they use VM clustering. So any single server failure will cause another machine in that cluster to take over the VMs that failed. Great. That is not what Windows Azure data centers look like. No. In Windows Azure, things look like this. You've got servers, but no SANs. And those servers are not expensive, high-end, fancy things. No. They're cheap pizza box servers. commodity servers, commodity disk drives. They're going to fail. Now, there's software that replicates data. So there's no fancy SAN, no expensive SAN. But data stored in those disks is protected against disk failures by replication. If you choose to build an app that runs in a single VM instance on a single server, you can do that. You can do that. But recognize that you're running on a cheap pizza box server, not on some fancy high-end thing with VM clustering. If that thing goes down, your app goes down. The model here is that you're building an application that runs as multiple instances that are all equivalent. A single failure should not take your app down. Azure expects you to build apps like this. And so, the Azure Compute Services are built with that assumption. Azure provides IaaS, which I earlier said was the core technology for public clouds and private clouds, in this thing called virtual machines. It provides another thing called PaaS, Platform as a Service, and a technology called cloud services. PaaS is similar to IaaS. Your app still runs in virtual machines, but now the VMs are managed for you. It's interesting. It does more work for you. There's also an option for web hosting and websites. Now, when Azure was first announced, and for its first several years, Azure provided only PaaS. Only PaaS. IaaS is relatively new. Why did Microsoft change this? It's really important to grasp this, because if you looked at Azure a year ago, 2 years ago, 3 years ago, all you saw was PaaS. And when all you saw was PaaS, you saw a much more constrained platform than is there today. Because the scenarios that IaaS allows are much broader than those that PaaS supports. Look at this. If I want VMs on demand for a dev test environment, and that's, by the way, is a very common place to start using Azure, is for dev test. I can do that with IaaS. I could not do that with PaaS. That's a scenario you couldn't really do until Azure added IaaS, which they've just done. I could not run a relational database, my own database, SQL Server, Oracle, in Azure with just PaaS. I can with IaaS. That's a big change. I really couldn't deploy most application packages with PaaS, but you can with IaaS. I could not use PaaS for disaster recovery because the VMs are not definable by me, but you can with IaaS. And there's more. If I want to move my current apps to the public cloud, IaaS supports that with some constraints. PaaS, maybe. So what's PaaS good for? Building new apps. I can build new apps with both approaches, but building new apps on PaaS can make all kinds of sense because PaaS provides you with this managed environment that's easier and quicker to deploy and run apps on top of. But recognize that PaaS is largely a new app technology. For many other public cloud scenarios, IaaS is the way to go. And because Microsoft has now added IaaS to Azure, the story gets much better, I think, for people like you. There are also various ways to store data. There's this thing called SQL Database. It was called SQL Azure. It got renamed, as things so often do. It's called SQL Database. It's effectively a managed version of SQL Server in the sky, more or less, conceptually. There's a NoSQL option called table storage that provides a key value store, if you're following the NoSQL world. And there's something called blob storage that's incredibly boring, but really important. Blob storage is like a big SAN in the sky that just stores big fat chunks of bytes. Turns out economically, commercially, that's the most important option here today, the most popular one today. One more thing. I keep on telling you about how these components that are changing in our world all go together. One of the most important examples of that is the way in which mobile applications overwhelmingly have some kind of cloud backend. So, to support that more effectively, Microsoft has chosen to add this thing to Azure called Windows Azure Mobile Services. It looks like this. It supports, at the moment, Windows Store apps, we talked about earlier, Windows Phone 8 apps, and iOS. Although we'll see Android support's coming soon. Windows Azure Mobile Services is actually implemented using Windows Azure websites. It runs on websites, and it uses REST and JSON for communication. Isn't it amazing how rapidly JSON has become the standard? And even JavaScript. It's amazing to me how rapidly JavaScript and JSON have become the standard way to do things in so many environments today. This reflects that reality. It also has support for a bunch of other things. User authentication using Twitter or Facebook or Google or Microsoft. Notification services using Microsoft or Apple's services there. You get a database automatically. You can just create this by saying, I want a mobile service. And it gives you one with a predefined SQL database for you. And there's more stuff. And the whole thing is actually built on Node.js, which means you can add your own code there in JavaScript if you want to. This stunned me when I first saw it. Microsoft building something so fundamental on top of an open source technology, Node.js? It's remarkable. But they're selling cycles here, not software. And so why would they care? It works. It's really interesting. So the connection there between our first topic and our second, there's a clear link between them. And this provides us with a nice segue into our last topic, which is ALM. What's happening here? Well, we've seen the changes in clients and in servers. How could we imagine that the changes in how we build apps in that world could not also impact ALM? Of course it does. Of course it does. And so governance is still there, but the classic split between development and operations, more and more in many environments, not all, but many, folds together to create this notion of DevOps. Married to that is the idea of continuous delivery, delivering code not just once every year or 2 years, but pretty much all the time. So let's discuss these things. And to do this, I want to start with a quick survey of what ALM means, because people don't agree on this. I want to be clear on what I mean by this. To me, the most useful way to think about ALM is to divide it into 3 aspects, 3 different things. Governance, which means making decisions about the app through its entire life. Development, which means, of course, building the app, the SDLC. You know, there are many vendors who use the term ALM synonymously with SDLC. This is just wrong. It's just wrong. Application lifecycle management has got to be more than just building the app. It's the whole process. And so ALM does not mean the same thing as SDLC. SDLC is the development aspect of ALM. Because I would argue strongly that operations is part of the story as well. Application lifecycle management. Keeping the app up and running is part of its lifecycle, clearly. So when you think about those 3 things, you can map them against the major events in an application's life. Because just like you and me, apps have big events in their life. Apps are born. Someone has an idea that says, let's build this app. Apps get deployed. They go into the world. Apps then eventually die, taken out of service. Just like us, big events in their lives. And so to think about the 3 aspects of ALM, it's most useful to map them against these 3 big events. Governance, for example, happens across the entire span. You're always making decisions about an app. Development kicks off after the idea, and then may have some things happening during operations, after deployment. Operations begins not long before deployment and runs the entire time the app is in service. And if you look at these things in more detail, you can see each one of them will have finer-grained breakdowns of what's happening in each of the spaces. So I think it's useful to think about ALM as having these three aspects, which you can understand in relation to the application's big life events of the idea, deployment, and end of life. Make sense? Great. To understand what is happening to ALM in the modern world, I've got to take a step back again and discuss one more thing that many of you may know cold. If so, please bear with me. It's the rise of Agile and iteration. Because here's what's going on. If you look at the SDLC aspect of ALM, that's where the notion of Agile fits in most directly. And so there, what do? Collect requirements, and we build code. Think about the conventional waterfall world. Who in the room is still working in an organization where most of your apps are built in a conventional waterfall style? Don't be ashamed. Raise your hands. Come on, it's all right. You're in good company. You people. I've seen very few hands. I think you're lying to me. Who in the room is using almost entirely agile processes in what they're doing? Again, I see not very many hands, maybe 1 in 10. Most of you probably use some kind of mix, water scrum fall, something like that, right? Yeah, it's a hard change. It's a hard change. But here's the thing. In the classic waterfall world, you define requirements up front, you build the software, you test it, you deploy it. Great. In that classic world, having requirements change partway through is bad. It means you screwed up. It means that you made a mistake. You got them wrong initially. Requirement change is a bug in the waterfall world. But the truth is that changing requirements means you've learned something new. It means that you're more likely to build the right thing at the end. Requirements do change because the world changes. And so the truth is that changing requirements is not a bug, it's a feature. It's a feature. It's a good thing. And so iterative processes, agile processes, embrace this reality by having multiple shorter iterations, each one of which gives us a chance to add, remove, modify requirements until we're done. That blue bubble, the code you produce, gets bigger and bigger. Great. That is the great thing about Agile. You are much more likely to build the right thing. Now, today, Agile has overwhelmingly come to mean Scrum. Can I ask again, who in the room is using Agile but is not doing anything even faintly like Scrum? Scrum is not what you're doing, but you're still Agile. I see a couple of hands, very few. Who's doing Agile and Scrum? That's your world. Yeah, right. Everybody else. Scrum has come to mean Agile, Scrum to a great extent today. And so in Scrum, what do? You've got this product owner who is the business representative, the guy who's paying for the application. This person creates and prioritizes the list of items to be done, the product backlog. The product owner and the dev team then choose a subset of this to be done in a single sprint, created the sprint backlog. The sprint, 2 to 4 weeks, is where the dev team actually creates, implements the items on the sprint backlog. And when you're all done, what do? You've got this unit of potentially deployable software that you demo to the product owner. You do this over and over and over until you run out of money or time or until the entire list of the product backlog is actually implemented. That never happens, but it could, theoretically, right? So that's a very simple picture of Scrum. Why am I telling you about this? Because to understand what is happening in ALM today, you must have this in your mind. That blue bubble, potentially deployable software. I get that every 2 to 4 weeks after every iteration. Well, why is it only potentially deployable? What if I actually deployed it? Why couldn't I do that? That's what it means to do continuous delivery. It's an example anyway. In general, what this means is just putting new code into production frequently. And one common meaning of frequently is after every sprint. Why not actually deploy that potentially deployable code? Why not? Microsoft, for example, tells us that in Team Foundation service, the cloud-based TFS service, they do this. After each 3-week sprint, they deploy that code into the cloud. Some consumer cloud applications actually deploy code at every build, every code check-in. Whoa, that's hardcore. That's really continuous delivery. Would that make sense for you? Maybe, maybe not. We'll come back to that. But this phrase can mean a range of things. But the key point here is it is enabled. This whole idea is enabled by the rise of the kinds of things we've been discussing. Remember, a Windows Store app, or for that matter, an iOS app or an Android app, can be updated frequently from the store itself. Updates are easy to do. And if I build an app that has cloud server logic, well, that code lives in one place. I update that code in one place. It is these new styles of app with cloud logic and mobile devices that let me think about continuous delivery, that make it possible. Now, could I do this with more conventional apps in my own data center? The answer is yes, you actually can if you automate deployment. For example, in the Microsoft world, you might have a developer like you who built some code. You check in new code at TFS, which does a build and runs the BVTs. Automated testing is important here. TFS can then deploy that automatically to the test environment where the tester does testing. And once it's done, you can automate with this thing called Orchestrator in System Center, deployment to production. You can actually make this happen largely automatically. So you could support something more like continuous delivery in your own world with the right tooling. In classic enterprise scenarios, you could. But think about this. Doesn't this mean that developers and ops folks must work together much more effectively? If I deploy code frequently, well, gee, the classic model of throwing the app over the wall to ops is not going to work. Hence, we see the rise of DevOps. In a very simple-minded way, DevOps just means making those two lines work better together. In more detail, DevOps means things like this. DevOps is organizational structure. You commonly have teams that include both devs and ops people. DevOps is culture. It's not finger-pointing, saying, oh, it's dev, oh, it's ops. No, it's saying it's us. It's our problem, not yours or mine. DevOps is process. Continuous delivery can, and I think should be seen as an aspect of DevOps. And DevOps is also potentially tooling. In the Microsoft world, this shows up again as connections between Visual Studio and the 2012 release of System Center. Look at this, one more example. It is possible in the new System Center to run an application with IntelliTrace turned on. IntelliTrace lets you keep all this data about the app, enough to let a developer essentially recreate the app's execution at some later point. And so an app running, being monitored by Operations Manager, can generate an alert that lets the operations person send back to TFS an error report that includes the IntelliTrace file. A developer can then use Visual Studio and use that file to actually rerun the app, find the bug, fix the bug, check in new code, once again, do the build, run the BVTs, and as before, deploy for testing, do testing, when testing is done, deploy it back. Tools can help with this whole DevOps idea if you choose to do it inside an organization like this. But should you? I mean, if you follow this space, you know that DevOps is all the rage. You know continuous delivery is a very hot idea. But does this really make sense for you? The answer, I think, is it depends. I think about it like this. There's a continuum. At one end is traditional dev and ops, the world most of us live in today. At the other end is this fancy, newfangled DevOps continuous delivery. I would suggest to you that the faster your app's requirements change, business requirements, the more to the right you ought to be on this continuum. So for instance, suppose you have an app in your organization that implements using, let's say, WPF clients and a .NET server on Windows server machines, some kind of stable business process that's wholly mission critical to your company. Does that call out for DevOps, continuous delivery? Probably not. Probably not. You want it to be stable, remain the same. Or maybe you're an ISV who's built some commercial application that's in use at 100 customers around the world in their own data centers. How do you do continuous delivery with that? It's hard. There are scenarios where it makes no sense. But there are other scenarios where DevOps, this approach, is exactly right. Suppose, for example, you've built some Azure-based application with Windows Store clients, iOS app clients. Well, boy, I can now do delivery of updates to my clients whenever I want from the stores. I can update my single shared cloud logic when I want to. Great, I can do it, and I may want to do it. Huge value there. So, to my mind, not every app should embrace this new approach. Some should not. Where is yours? It's up to you. And there you have it. A quick look through a lot of stuff. The kinds of apps that we can create are evolving pretty darn rapidly. And so all of us have to evolve as well. The three categories of changes here I've talked about: new clients in the PC Plus era, the rise of public cloud platforms, and the changes in ALM this brings about, reflected in DevOps and continuous delivery. I began my talk about an hour ago by commenting on the fact that people who work in this field like change. And we do. We do. But we also like the fact, as I said before, that the work we do is so important. It's so important. So to embrace, I think, the things that let us build more, newer, cooler, more awesome apps is useful. It's valuable, not just to us, but to our customers, to the world at large. It's important. And not only that, I think these changes make our lives so much better. My last thought is this: it is a great time to be a developer. Thank you.